Okay, y'all. So today we're going to go over all four of the Unit 2 quizzes, 2.1, 2.2, 2.3, 2.4 in that order. I'm not going to go through every problem from all four quizzes. You guys will see some of the problems might be different from yours as well. I'll try to talk about some of the differences and similarities that you might have on there, but that's the idea. So let's start off with this one here, quiz 2.1, transformations. This is the one that I had you all do on your own. So let's see how well you guys learned these. So this first one, I don't expect necessarily something like this to be on the test this week, but it might be. So I'm going to show you guys a little bit of this one. So here they'll give you two random graphs like this. This isn't a particular function. It's like a combination of functions here. And what it's asking is, it's just asking, hey, look at g of x. It is a transformation from f of x, right? So f of x turned into g of x, and it wants to know how. So the thing that I hope you guys can see here, right, is that g of x actually got squished horizontally, right? Take a look at the x values, compare them, right? If I look at this one here at -1, well, I'm sorry, -2 on f of x, it's at the same point as at -1 on g of x. The point that was at 1 on f of x is now at 0.5 on g of x, and so on, right? But notice how the height did not change, right? So this is only a change horizontally, not a change vertically. So we would say this is a horizontal compression, I think is what I would call it. Let's see what they would call it on Canvas itself. I think they might use the same terminology here. Yeah, horizontal compression is what they have for it as well. Let me actually zoom back in here. There we go. So yeah, I would call this a horizontal compression. This happens to be the same exact problem here. Notice how it's going to ask you about one of the points here. It tells you, hey, this graph of f of x, the original graph, ends at 4, 6. That's this point here, right? This 4, 6. But in the new graph, g of x, it ends at 2, 6. So you can look at what changed, right? Look at what changed. The x value is what changed from the points. How did it change? You could think of it as -2, but actually it was cut in half, right? It was actually divided by 2. So you're looking at, because this is a horizontal change, we're talking about the x values in this one. The x values have been multiplied, in this case, by 1/2. Yeah. So like I said, every x value, if you look at, say, f of -2, this is the same as g of -1, right? It gives you the same point here, which is what it's asking you in the last little drop down. Some of these in the quiz, you can either have this one, or you might have the one that's the opposite, where actually the graphs are just flipped, I believe, and it starts you off with the skinnier one and it goes to the wider one. So that one you would say, oh, the x values are multiplied by 2 and it's a horizontal stretch, okay, instead of a compression here. So any questions on this one? Question number 1, how to deal with these. You're going to want to definitely look at what changes between them. Is it the y values that are changing, the x values? You might have something like this on the exam tomorrow or Wednesday, whenever you're taking it. But, this is just really a review problem for transforming a graph in general. This one I wanted to talk about because this one might be, strange for some of you guys on the quiz. This one is saying this was a matching problem, right? So here it gives you all sorts of different equations to look at. They're all transformations of x squared. So you have 2x squared, parentheses 2x squared, 1/2 x squared, and quantity 1/2 x, quantity squared. So you have to be able to match them. So first thing I can tell you all is that, well, what you're going to want to be looking for is whether that number is on the inside or in the outside of the parentheses. Hopefully you can tell that that's the big difference here, right? In two of these, you're going to have a change on the inside. What this is telling you is that the x is going to get multiplied by whatever number's in there. So for example, in this one, let's say I let x equals to 1, right? What would y equal to? Well, y would equal to, let's see, 2 times 1, and then that squared would equal to 2 times 1 is just 2, 2 squared is 4. So I would have the 0.14. Now, none of these have the 0.14 in it. So you have to think, okay, well, how could I get one of these points then? So what's happening in 2x squared is that whatever x value I'm plugging in, it multiplies it by 2, right? So let's instead try, I don't know, something like x equals to 0.5. If x was equal to 0.5, then I would do 2 times 0.5, then square that. What's half of 2? What's 0.5 times 2? 1. So 1 squared would give me 1. So I'd have the 0.5 and 1, which you can see is this guy right here, C. So the first one here should be C. And you're kind of just looking for one of those ideas. You're looking for whether or not you're multiplying the x or the y. Look at the next one. The next one, you start off with whatever x you're dealing with. Then you square it. Remember, order of operations means that PEMDAS, right? You guys remember PEMDAS? Means that you're going to use the exponent. You're going to square, in this case, before you multiply. In the first one, we had parentheses. So first you had to multiply 2 times x, then you square it. So that's really the difference between this, okay? So let's say again, let's try x equals 1 here. So I would do 1/2 times 1 squared. Well, that's just 1/2 times 1, or 1/2. This would be my y value, right? So I would look for 1/2 or 0.5, right? So do we have anywhere where I have 1 and 0.5? That would be A for this guy. Yeah, and that's kind of the idea. You want to go through and take a look at that. If 1 doesn't work, you might want to try 0.5 for x on some of these. And you're just trying to figure out which one matches that first point, okay? So the last one on here, let's see, have we, oh, I missed the very first one, huh? 2 times x squared up here. So again, this one, I'm gonna say, let's turn x equals 1, right? 2 times 1 squared is what? What does that end up being? Just 2, right? Because you square the 1 first, then you multiply it by 2. So you get 2 for y. So that would be the 0.1. We plugged in 1, we got out 2. Do I have the 0.12 somewhere? Ah, yes, right here, right? So by process of elimination, you can figure out that the last one here should be D, yeah? On your test, try to use some of those test taking strategies as much as you can. Process of elimination is a really great tool for you guys to use. Just, but always double check yourself, okay? So like in this one, I'm gonna double check. Here it's telling me x is equal to 2, then the y is equal to 1. Let's try it. I would do 1/2 times 2, then square it. 1/2 of 2 is 1. 1 squared is 1. So I plugged in 2, I got out 1. Yes, that's the point that's right there. Yes. So just, double check yourselves on your test tomorrow. You can try things like plugging in values if you're having a matching problem on there. I kind of doubt that they would show you one like this as well. But again, this is part of the review for the test that I just wanted to give you guys a few opportunities to look and see how you can solve problems like this. Any question on this one? This one was number 3, by the way. I skipped number 2 because what was number 2 on this quiz? Number 2 is just, oh yeah, matching the parent functions. So you guys need to know your parent functions pretty well. You need to know that this is a square root. Yeah, this is the absolute value of a function. This is a cubic function. This is a parabola, right? It's a quadratic function, x squared. They're on the door when you walk in. When you come in for your test, take a look at those. Make sure that you can recognize the graphs of your general functions. That's all number 2 was. So let's move forward. Now, this one's a cool one, question number 4. This is one of those where you had to type in your answer, correct? So make sure that you do a little bit of practice trying to type in. I notice students tend to skip these problems on my quizzes, and I'm not sure why. So we've got to work on these a little bit more.
I think it's because we usually save them for last and then we forget sometimes.
Maybe.
That's at least what
That is an optimistic
I do that
interpretation,
a
I
lot.
think. Okay, that's fair. So in this one, it says write an equation for this graph below. What is the main graph that this one comes from? What's the parent function of this? Square root is the parent function. Okay. Now, what we want to be able to use here is a times your function x, x minus h plus k. Okay, where a is going to be the multiplier, it's going to tell you how much it gets stretched or compressed. H and k are like your vertex, right? Now, not every function has a vertex, but you can think of this as being your h and your k. All right, now our function, like you guys said, is a square root function. I can already come up with h and k. My coordinate here for this guy is at -4 and 2. Now, the h coordinate is always going to be the opposite sign when it goes into your equation, right? So instead of -4, I'm going to write +4 inside the square root. And then my k value, the y value of the vertex, is always going to go on the outside. It stays the same. It has the same value. So I'm going to leave it as +2 for k. Now, the only thing we need to figure out then is the a value here. What number is multiplying my square root? Now, typically a square root function looks like this, right? If you look at the square root function, you can kind of see a variation of how how the graph actually looks of it, right? Kind of similar to that. If you were to do something like this, right? You can kind of see the graph in there. Now, ours clearly is going the reverse direction, right? It's going downwards instead of upwards. So we know that our number should be what in front here? We should have a negative number. Now, to figure out what that number is, what you need to look at is the very next point on your graph. Okay, typically a square root function, if I take the square root function itself, my very next point should be 1 and 1, 1 to 1, because that's how the graph of that goes typically. Most graphs, like a parabola, also has the same thing going on. When you plug in 1 into a function, you get out 1, at least into a parent function. Okay, so in this case, if you notice, you go 1 to the right. How far down is this point away from it? 3. So that's the number itself. -3 is the number that you would use here. Okay. Now, if let's say this was facing the other way for whatever reason. Let's say I gave you one that looked like this instead. Okay.
At the same point.
Yeah, that would be weird, huh? At the same point. Well, all I would change is I would put now parentheses here and a negative inside here. That changes. So notice how when the negative's out front, it's like you're changing the y value. You're multiplying all the y values by a negative. But if I put the negative on the inside, I'm changing all the x values to negative. And so it would change it. It would be what's called a horizontal reflection. Okay. When the negative's on the outside of the function, it's a vertical reflection. It's going to flip vertically downwards. Okay. You've probably seen that before in parabolas. It works the same here. Okay. Everybody cool with this? So question number 4, it's one of these where you want to use the pattern that you see here. Sometimes it's 3 down. Sometimes it might be, I don't know, 2 down. I've seen problems where it's, like 6 down or something like that, or in this case, 4 down. Yes. So make sure that you're paying close attention to where that point is. How far away vertically is it from your starting point? That'll give you the number that you're multiplying by. Okay. Even if it's like, say, an absolute value function. Let's say I have an absolute value function that looks like this. Yes. Well, I can tell that it's going to be 2 times the absolute value of x, because if I go 1 to the right, I had to go 2 up to get to that next point. Same thing happens in a parabola. Let's say I had this in a parabola. Same thing. It would be 2x squared. Okay, let's say it was a cubic function like this. Again, 1 to the right, 2 up, it's 2x cubed. That's what you would see there. Yes?
So it's just always to the right.
Always go 1 to the right, however far you have to go up or down is going to tell you what that number is. If you have to go up, it's positive. If this was flipped, let's say I had a parabola, okay, that looked like this. Here and here. Okay. Notice how I have to go 1 to the right. I went down 3, so it would be negative 3x squared here. Okay. Now it doesn't have to be centered at 0, 0. It can be centered anywhere. So I could do it like say here and go
You just do it with the highest.
this, right? And I could still figure out that it would go 1 to the right, 1 down. So I would have a negative x something squared plus something else in this case, because I'd be looking for the vertex here. So that's how you can tell. That's like the cheat. That's the really quick and easy way of figuring out what that a value is in any transformation of a parent function. We can use that on number 6 actually right here. Yes. So here they're giving you the same thing here. First of all, so this one they ask you to choose a bunch of different things. They're going to ask you what function this is. They're going to ask you, instead of a, they're using g here for this particular one. They're going to ask you if it's positive or negative. They're going to ask you how far to the right and left, how far up and down is that vertex. Right. So let's see if we can figure out. Let's see if we can figure this out. Okay. Now, in this one, what kind of function is this? It's going to be an absolute value function. Okay. Is it positive or negative? Negative. Now, I just told you guys that if I go 1 to the right, all I have to do is look up or down to see how far it went. In this case, though, I can't tell because it didn't go down all the way 1, right? So what that means is that it's going to be a fraction. And the way you can tell with an absolute value, it's the same way you can tell with the linear. I can go to the very next point that it gives me and basically find the slope of this line. What would the slope of this line be? Let's see. I would be going down, so we know it's negative, right? So down how far? 2, and to the right how far? 3. So because of that, I know that my number in front of the absolute value is going to be negative 2 over 3. That's the slope of the right side. Is always going to give you the a value there. Okay, in this case, g. So we already know that it's going to be a negative. We know that g is going to be 2 over 3 because that is the slope here, right? Negative 2/3. Now let's look for h and k. H and k is going to come from the vertex. The vertex is at, let's see, 2 and 3. Oh, that's convenient. It's actually at 2 and 3 too. So this is your h, this is your k. However, be careful. In the actual equation, you're going to write x minus 2, right? Because h is 2. Oh, it's going to be absolute value of x, right? I'm not sure how they write. They might actually write it out absolute value. H is going to be 2 because that's the value of the vertex there, the x value. K is going to be. So with these, again, the vertex is pretty easy to find. We have done much more complicated things already than figuring out where to find the vertex. But what I really wanted to talk about was, yes, that finding the slope of it to use as a. And that's kind of what you're doing when you're looking at these as well, right? You can think of that as being the slope down 3 to the right 1, negative 3 over 1 is negative 3 that we got here, right? So kind of just use that same idea when you're working through these transformation ones, if they give them to you. So that's about all I'm going to go through on transformations. Like I said, hey, it was a quick one, right? I just wanted to make sure to cover some general ideas in this. They're probably not going to ask you a ton about transformations, though that's changed from year to year. Some years they've asked maybe 2 or 3 questions. Other years it's been like half the test. So they tend to, it just depends on how nice they're trying to be to you guys. Okay. Because I think these in general are the easier ones. All right. How are we doing so far? Everybody okay? All right. Okay. I'll give you guys a moment if you want to join up, link up yours, quiz 2.2, if you want to open that up and take a look at what your responses, maybe previous responses were, or if you want to maybe work a couple of these problems out together, that'd be okay with me too. This one's the quadratic formula and complex roots one. The first question on this one, everyone, is following what we did in the exploration 2.2. I'm sorry, 2.2.2, I think it was, right? Where we actually did where we derived the quadratic formula. Yes. I'll take a look at it after we're done here, and I'll make sure that it has more attempts. When I did it, I could have sworn earlier I checked it. It said 100 attempts. Yeah, for quiz 2.2. But I'll double check that, and we'll see if I messed up or what happened there. Just remind me at the end of this. Okay, so this like I said, question one is just a recap of doing that. If you want to take another look at that, if you don't have your notes, I would suggest Googling deriving the quadratic formula, and it'll show you steps similar to this. I don't want to get into it too much right now because we have a limited time. So let's start off with problem like question number 2 here. This is just your basic stuff, Gesundheit. Here's just a little bit of review. Let's say I have a quadratic formula or a quadratic equation. This one's general, very general, standard form, ax squared plus bx plus c. A, b, and c, of course, would be numbers, typically. But we want to find h and k, the vertex. Now, remember, I gave you guys formulas for this. H, you can find the x value of the vertex by doing negative b over 2a. Okay. And then you figure out what value that is, and that's your x value of your vertex. It's also the equation for the axis of symmetry, by the way. Okay, is negative b over 2a. Now, to find the y value of that point of your vertex, well, you just plug in f of h, okay, into the equation. Whatever number that you find for h, negative b over 2a, you plug it into the equation and you get the value. In other words, you're finding the f of negative b over 2a. So oftentimes I write the vertex as this point here, negative b over 2a, and f of negative b over 2a. All right, so let's move on to another question on the quiz. I'm skipping question 3 because this is just kind of going over some aspects of imaginary numbers that are pretty easy. Remember that the imaginary number is the square root of -1. I squared is -1. A in the complex number a plus bi is the real part. B is what we call the imaginary part. And when a quadratic function has complex zeros, the graph does not intersect the x-axis. Okay, so when if you use a quadratic formula and you get complex numbers as your answers, that means the graph doesn't actually cross the x-axis, at least not the actual real x-axis. It does an imaginary like that. All right, that was just really, really quick. I wanted to tell you know, I gave that one to you. Again, that question is not going to be on the test. Just a quick review of the concepts. Question number 4, though, is one of those where you have to actually answer. So here's where we're going to get to use the ideas that we learned before about finding the vertex and also finding the zeros. So let's start with A. This is one you have to type in. So I'm going to write down that the vertex can be found algebraically this way by the coordinate negative b over 2a and f of negative b over 2a. So I'm going to go ahead and start off by finding the x value here. So my a is equal to 1, b is equal to -4, and c is equal to 13. That's going to come in handy later when I need to use the quadratic formula. Okay. So in this case, I'm going to go ahead and plug in my negative
B is -4, over 2 times A is 1. -4 is just 4. 2 times 1 is 2. 4 divided by 2 gives me 2. So I know already that the X value of my vertex is 2. Now to just find the Y value of the vertex, to do that, I need to plug in 2 into my f of x equation. In this case, f of x is equal to x squared. So I'm going to do 2 squared minus 4 times 2 for x plus 13. So 2 squared, of course, is 4 minus 4 times 2 is 8 plus 13. -8 and 13 is equal to positive 5. Messing that up. Let's just make this a plus 5, right? That's -8 and 13. 4 plus 5 gives you 9. So we get the vertex is 2, 9. Bless you. So this is how you're going to use that vertex formula that that I showed you guys earlier. To get the Y value, you just plug in that number. Okay. Now for the next section in this, we actually have to find the zeros. So to find the zeros in the quiz itself for 2.2, you don't have to show the steps on this. You just have to get the answer. Okay. But to get the answer, we need x equals -b plus or minus the square root of b squared minus 4ac all over 2a, the quadratic formula. Now earlier we wrote down that a was 1, b is -4, and c is 13. All we're going to do is plug these numbers in now and simplify until we get our solution for x. So x is going to equal to -4 plus or minus the square root of -4 squared minus 4 times 1 times 13 all over 2 times 1. My first step, I always plug everything in really carefully with parentheses to make sure I don't make any silly mistakes when I have like negative and negative or squaring a negative number. Okay. So my next step, I'm going to start to simplify a little bit. -4, those cancel. That's going to give me 4 plus or minus. Now on the inside, 4 squared is 16 minus 4 times 1 times 13 is 52. So you end up with -36. I'm going quick. I did this one earlier today. I'm going quick so that it's a little bit easier for us. But yes, you would do this work. You'd subtract it. And then divided by 2 times 1 is just 2. Now, luckily for us, on the inside of our square root, we have a perfect square. Of course, what kind of number is this going to be for x eventually? Complex number, imaginary, right? So we're going to get 4 plus or minus. The square root of 36 is 6, right? So in this case, since it's -36, we're going to call it 6i divided by 2. And since both of these numbers are divisible by 2, we're going to say that x is equal to, well, 4 divided by 2 is 2, plus or minus 6 divided by 2 is 3i. So those are two solutions. Remember, x equals 2 plus 3i, and x equals 2 minus 3i. I want you guys to remember that earlier we found that the vertex of our parabola was at 2, and guess what the real part of our parabola is? It's 2. Okay. So we know that if we plugged in a complex number with 2 for the real part, you're going to get a real answer. Okay. Depending on what you plug in for the imaginary part, you'll find a 0 for this. All right. So make sure that you can use the quadratic formula. Make sure that you know how to find the vertex, and you should be good to go for the test over this subject here. Let's do, I think, one more from this one. This was just the same. This is really just more of the same. Okay, in number 5, same type of problem. Here they're asking you to find the vertex. I'm not going to get into that again. I don't want to repeat myself in today's study session. All right, but you saw how we worked it out. Now, here it's asking, hey, so I'll do the things that are a little bit new here. Hey, what's the y-intercept? Well, here they're giving you a big clue. Whenever you find a y-intercept, it's telling you, hey, what happens when the x is equal to 0? So if I plug in x equals 0 into f of x, I'm going to get 0 squared minus 6 times 0 plus 10. Anything with the zeros are just 0. So f of 0 is equal to 10. So our y-intercept is at 0 and 10. Okay. To find the roots of this, you would again use the quadratic formula. And again, I'm not going to go into that. Okay. But if I were to take really quick negative b over 2a, or -6 over 2 times 1, I know that the x-intercept of my the x variable, of my vertex, the x-coordinate is going to be, well, -6 is 6 divided by 2 is +3. So I know that if I were to plug in 3 plus 2i, I'm going to get a real number, not an imaginary number, because this 3 matches the 3 from the vertex. Okay, I'm not going into the whole thing. And it might even be a 0 to that. Remember that when you plug in an imaginary number, in fact, let's double check this. I'll do this one with you guys. When you're asked to find an imaginary number evaluating into a quadratic, let's try it out. 3 plus 2i. Remember that the first thing you're going to do is you're going to square that imaginary number. 3 plus 2i squared minus 6 times 3 plus 2i plus 10. Be very careful. Don't make the mistake that everybody wants to make here and go, this is 9 plus 4i squared. That is not true. Yes, it's not, does not mean that you're squaring both numbers. What it means is that you're taking 3 plus 2i and you're multiplying it by itself. I'm going to work that out really quick over here. 3 plus 2i times 3 plus 2i. You need to use FOIL here to make sure that you get the correct answer. 3 times 3 is 9. 3 times 2i is 18i. Whoa. I was going a little ahead of myself here. Let's try that again. 3 plus 2i, 3 times 2i is 6i. 2i times 3 is 6i again. And 2i times 2i, here's where we're going to get 4i squared. Now, we can start to simplify this a little bit. 9 plus 6i plus 6i is 12i. But remember, 4i squared, I squared is actually equal to -1. So this is really -4. 9 minus 4 is going to be 5, right? Plus 12i is what this really becomes. Do you see how you can't really, you're not really going to be able to get that answer by just looking at it and squaring those two things. You actually have to FOIL it out. Make sure if you spend time doing that, don't try to just do this in your head. You must do it by hand, okay? And be careful about it. The rest of it, though, is pretty simple to do. -6 times 3 is going to give me -18. -6 times 2i is going to be -12i. Hello, that's good to know. Plus 10. If you notice, the -12i and the positive 12i are going to cancel each other. Now I have 5 minus 18 plus 10. 5 minus 18 is going to give me -13. -13 plus 10 is going to give me -3. So this complex number right here, is that an x-intercept? Is that a 0 of the function? Is that a root? No. If it was a root, it would have given you x equals 0 here. But instead we got -3. But we were right. Remember when I told you guys earlier that it would be a real number and not a complex number? Well, that's because it started with the 3, right? And again, make that connection that the 3 that is the part of the vertex, the x value, is going to kind of give you the hint that that's going to happen. But just be careful when you actually work these out. You do want to work it out carefully. They're most like, I've seen this one on every single test for Unit 2 that I've ever given, so try that out. Have I not? Did I not give you that on? So something went screwy on this one, clearly. I will go ahead and make sure and adjust that in just a little bit, okay? So that way you can see that. Now, this last one says, where does f of x equals g of x? So this one, they give you a function for f of x, which is the one we were just working with, right? X squared minus 6x plus 10. And it wants to know where is that equal to g of x, 5. So to solve this one is very simple. All I'm going to do is make sure whenever you're trying to solve a quadratic equation, what you're always trying to do is set it equal to 0 first. Okay, so really we're looking at x squared minus 6x, 10 minus 5 is plus 5 is equal to 0. And for this, you could either use the quadratic formula again, but this is actually a special one. This one can actually be factored. Yes. This one, and we'll get into factoring more and more as we go forward, but this one factors to x minus 5 times x minus 1 is equal to 0. So your solutions, if you take each one of these and set it equal to 0, would be x is equal to 5 and x equals 1. Again, you could have also found those two solutions by doing the quadratic formula. I'm just showing you guys what the answers are here and it's a quicker way to solve it in the interest of time. All right. So that has taken us from quiz 2.1 and now 2.2. All right. Quiz 2.2, that one only had 5 questions to begin with. Let me take a quick moment here to pause. And we're back. So let's take a look at quiz 2.3. This is the conic sections one. This is the one, we haven't seen this in a while, so I just want to briefly go through a few of the problems on here to just get you back in the swing of things. Honestly, guys, the only things I would really, truly expect to see from this quiz on the test are the basics, okay? Hey, can you match the graph in the equation? And 2, can you put it from general form to standard form? Okay, so let's take a look at some of these. Here, they're going to ask you some of the locus definitions. They might ask you these on the quiz, so make sure that you go back and take a look at your responses on these so you can remember what the locus definitions were for those. This one's actually pretty fun. Question 2 here, okay? So here they give you the big general form for any conic equation. They're asking you, hey, for each one, can you tell me something about these? So remember in a parabola, you only have one of the variables that's squared. Okay, so you either have only x squared or you have only y squared and not the other one. The other ones would just be x's and y's and a number. So that means that for a parabola, a equals 0 or c equals 0. Okay, on a circle, remember that you always end up having it equal to the radius, which means you divide both sides by the same thing. In this one, it's, I did the wrong one here. A has to be equal to C. So if you see a general equation like this and you have like 5x squared plus 5y squared, you know that's going to be a circle. Or if you have 3x squared plus 3y squared, it's going to be a circle. If you have just x squared plus y squared, you know it's going to be a circle. Okay. An ellipse, A and C will have the same sign, but they're not equal. Okay, so both A and C will be positive, but they'll be different numbers. So it'll be like 2x squared plus 3y squared, or 4x squared plus 7x squared, or negative 3x squared minus 8xy squared. Okay. With the hyperbola, though, A and C always have opposite signs. So you'll see 3x squared minus 5y squared, something like that. Or you might see negative 2x squared plus 3y squared. So look out for those. I thought this would be helpful to share with you guys because this will make it easier for you guys later when you're trying to look very quickly and say, hey, here's my equation in general form. Which kind of shape is it going to make, right? And if you can tell really quickly using this shortcut, it makes it a lot easier and faster for you to get through these problems. So let's go on then to question 3. Which equation makes this graph? So what kind of graph is this? What kind of shape is this? This is the ellipse, right? Now, in the ellipse, remember what we just said, right? This is here, I'm gonna show you guys exactly how you can use what I just taught you, right? In the ellipse, A is not equal to C, but they have the same sign, right? So let's see if we can eliminate anything. That's usually, like I said, process of elimination is going to be helpful here. This one right here is the equation of a circle, yes? Because the equation for an ellipse looks like x minus h squared over a squared plus y minus k squared over b squared equals to 1. So we can already eliminate anything that's not equal to 1. So I'm going to go ahead and just cross out this one and this one right away. We can also get rid of anything that has the minus in between. If your fractions have a minus in between, that's not an ellipse, that is a hyperbola. So this one right here with the minus in between, that should be a hyperbola equation. So that one and that one are going to go away. Do you see how quickly this actually falls apart? And really, if you know your equations well enough, you can very quickly go from having, I don't know how many, this was 6 options, now down to just 50-50 shot. Yes, you already eliminated very, very quickly what you need. So the next thing I would need to do, to figure out, to distinguish between those two is basically figure out where the center is of this ellipse and how long the 2 different axes are, 2 different radii. So I'm going to go to the longest one here and then this one in the middle right here. Let's see. If this is 0, 0 over here, then I have the center is at 2 and -3. So I know that I'm going to have something like x minus 2 squared. And then this one's going to be y plus 3 squared. The x and the y are always opposite in these. Okay, for both of them. So right away, we already have our answer. I don't even have to worry about anything else. I don't even have to finish doing this problem because I can already tell that this is not it because this one has x plus 2 squared, which is not what we're looking for here. Yeah. And so this would be our guy. Now, the other thing that you can remember is that, hey, whatever the square root of this is, that's the longest one. That's going to be your A. That's going to be the longest axis. So the square root of 25 is equal to 5, right? And take a look at how long this is. 1, 2, 3, 4, 5. Yes, that distance is 5. The square root of 16 is 4. And that's how long the shorter axis is. 1, 2, 3, 4. So there it is, right? The vertical axis, the horizontal axis that gives you, it gives it to you here, 25 here and 16 here, equal to 1. All right, so again, using that idea, using a few ideas, knowing the equations just a little bit can really, really help you eliminate answer choices, which in this case is supremely helpful, right? As soon as you do that, all the other ones become pretty simple. Now, in this one right here, question 4, this is going to be a parabola. Notice how you only have one variable that's being squared, right? Now, when I have x squared, when the x is squared like in this one, I know it's going to be a vertical parabola because this is generally how parabolas we know work. If the y is squared, you're going to have a horizontal parabola, okay? If it's positive, it's facing right. If I have a negative y squared, it's going to be facing left. And the negative usually is going to happen here, okay? Now, in this case, because this one would be a positive right in front of this. Remember that this is the distance between the vertex and the focus. In this case, it's telling us that the distance between the vertex and the focus is a negative, which means this is going to be going down this way. Our focus is somewhere down here, meaning it's -2, like this. The only thing left is just where the vertex is. When it's written in conic section form, the vertex in this case is going to be just the opposite of these two, -1 and +2. So now I need to look for a vertex at -1 and 2 that's facing downwards like this. Okay, so in this case, Boom, right here. Pretty quickly, we can figure out a problem like this one as well. Okay, based off of that information that it gives you. If that 2 over here, instead of a -2, if it had been a +2, the parabola would be facing upward. If this was a y, if the x and the y were flipped, then it would be going, in this case, the negative would make it go to the left. If this was a positive, it would be facing to the right. So make sure that you look over those different types of graphs of changes to the parabola, because these are fairly simple so long as you know the general idea of it. So now this one. So hyperbola graphs, these are more rare. Okay, these are rare to see on the exam. Personally, I usually see ellipses, circles, maybe parabolas on there. Very rarely have I ever seen a hyperbola on the actual exam, but it happens sometimes. Okay, remember that you can tell whether it's going to be horizontal or vertical parabola based off of which value comes first. Okay. In this case, because the x value comes first, tell me what kind of hyperbola am I going to see here? This is going to be horizontal. Okay. It's going to be a horizontal hyperbola. If you're working on this quiz before the test, what I would suggest is going to Desmos, really, and just making sure that you can match it. Okay. You're not going to be able to have access to Desmos on the test, but at this point, I just want you to get that idea across. So again, if it's a horizontal one, already this one is off the question, this one is off the question, and it's really just a matter of which one of these. Now remember, for the hyperbola, what you're, again, it's going to come down to where is the center of this hyperbola. Okay, so if I look at these two, I'm going to look at where the kind of 2 points that are closest to each other in the hyperbola are. That's going to be this axis right here. Okay. And I'm going to kind of figure out how long that is. 1, 2, 3, 4, 5, 6. So I'm going to go 3 to go into the middle here. This is my center for this graph. This graph has the center at 1 and -2. This graph over here, let's see, I'm going to go find this. This length is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 1, 2, 3, 4 here to find. Actually, wait, 1, 2, 4, 1, 2, 3, 4. This one has a little bit of a weirder center at -0.5 and 2, it looks like. Okay, so you want to find the halfway point there. Clearly, you guys can see which one is going to be the answer here. Here's 1 for the x, so it's going to really be. Uh-oh, what happened here actually? Let's see. I think I miscounted. Didn't I miscount? I must have. 1, 2, 1, 2, 3, 4, 5, 6, 7. Oh yeah, I definitely miscounted. Here should have been the center. Okay, that's better. -1 and 2. Okay, my bad, guys. So be careful when you're counting. All right, that can be an easy mistake to make. But in this case, notice how they're at opposite values. In this one, based off of this, my center should be at -1 and +2. Always the opposite signs of what you see in the actual equation is where the center is. So when it comes down to it, it's this one right down here, -1 and 2. So make sure that you know how the equations work. These are the most general ones I would expect to see on there. Hey, match the equation with the graph. Okay, that's one type of question I would expect to see. Another type of question I would expect to see is one like this, converting from general form to standard form. There's a few of these on here. I'm going to not go through all of them, but I do want to pick one to go through to just remind everybody of the process of doing this. It's really all about completing the square. All right, so I'm going to go ahead and write this one out for us here. 4x² + 9y² plus 48x minus 72y plus 144 is equal to 0. So what we want to do here to remind you all, first things first, always make sure that you move the constant over and also gather your variables together next to each other. So the x's right together, 4x squared plus 48x. And then I'll write my y's together, plus 9y squared minus 72y is equal to negative 144. Now, what I failed to do, well, what we're going to want to do next is making sure that the first number for your squared are both equal to 1, right? So what I'm going to want to do here is I'm going to want to factor out a 4 from both of these. So I'm going to divide out a 4 from both of my x's. So that would be 4 times x squared plus 12x. Here I'm going to put the box, as you guys remember, yes? And it's been a while since we've done it, so that's why I want to make sure you see it one more time. And from this one, I'm going to want to divide out 9 from both of these. So I'm going to have plus 9 times y squared minus 8y plus a box is equal to 104, negative 144 plus 4 times a box plus 9 times a box. On the other side, remember, it has to stay in balance because of these numbers out here. You also have to include them out here as well. Now, for each one, we're going to complete the square, right? So remember, that's the b value divided by 2 and squared. So we're going to take our b value, which is 12, divided by 2, and then square it. I like to work it all the way out. That way I get this number, which is what we're going to use later to factor. 6 squared is 36 here. So this one's going to end up factoring to, I'm going to go ahead and just do the factoring first. 4 times x plus 6 squared. Again, that number before you square it is what ends up going right in there. For this one, I'm going to do the exact same thing. I'm going to take my b divided by 2 and I'm going to square it. This time my b is negative 8. When you divide that by 2, you get negative 4 squared is 16 in both of those boxes. So factoring this guy down is going to be plus 9 times, again, using this number, y minus 4 squared is equal to, now we have to actually work these out really quickly. On the test, give me one second. So let's see. So here, this is where we actually have to do a little bit of math, right? So we're going to need to do 4 times 36, which is going to give us 144. Oh, that's convenient. That means these will cancel. And then 9 times 16 is going to be, oh, that's also 144. That's really convenient, isn't it? So this ends up being 144. Hot dog. Yeah, that works out, right? So the last thing we need to do is divide both sides by, divide everything by 144. So I'm going to do that here. I'm going to do that here. I'm going to do that here. And of course, here we're going to end up with x plus 6 squared over 144 divided by 4 is 36 plus 144 divided by 9. This is going to be y minus 4 squared over 16 is equal to 1. So now we know that we have the equation for an ellipse, right? Where the center is at -6 and -4. And from that point, I know that horizontally, it's gonna go out 6 to the left, 6 to the right. I know it's gonna go 4 up and 4 down because that's the square roots of these numbers down here. My ellipse is not drawn to scale at all, so we're just gonna pretend that that's how it should be, okay? So we can tell it's a horizontal ellipse because the number under the X is larger than the number under the Y, yeah? So there we go. Good reminder, a little refresher over conic sections there. I hope this helps you out a little bit into doing this. Oh, was it positive? Oh, yes, you're correct. +4. Sorry about that. Good catch there. Make sure that you're really careful there and you're not also teaching a class at the same time as you're taking a test tomorrow. Otherwise, it's really easy to make these kind of mistakes. All right. That's always my excuse, is that I'm busy teaching a class while I'm trying to do math. Try not to be distracted too much, okay? So here in this particular one, they give you all sorts here to work on. I wouldn't expect too much about the focus and the directrix on this, but you're gonna do the same type of thing with question number 9. If you need to, make sure that you know how to complete the square for this guy. Go back and look at some of those videos that I've already posted on doing the conic sections with parabolas. Goodbye. Last thing I wanted to go over are some matrices problems here from quiz 2.4. Be careful doing row operations, guys. Make sure that when you do them, that you actually write it out here. They're actually starting you off with this particular matrix here. 1, -1, 0, 1, 0, 0. It's the augmented matrix. And they're asking you to do a few row operations. Make sure that you can do these. The first one that asks you to do looks like this. Row 2 is equal to row 2 minus row 1. So what I always do is I always look at my row 1, row 2, row 3, right? We're going to replace row 2 with row 2 minus row 1. So I'm going to write out row 2, 1, 0, -1, 0, 1, 0. And I'm going to subtract row 1. So I'm going to make all these negative. I'm going to multiply by -1, right? And then I'm going to add them together. So this is going to become -1, +1, 0, -1, 0, 0. I'm going to add these together. This is going to become 0, 1, -1, -1, 1, 0. This is my new row 2. So now I'm going to write in 1, -1, 0, 1, 0, 0. 6, -2, -3, 0, 0, 1. And my new row 2, which is 0, 1, -1, -1, 1, 0. Okay, I don't want to go through all of this, but we'll try to do as much as we can here. The next one would be to do row 3. We're going to change row 3 by doing row 3 minus 6 times row 1. So I'm going to write row 3 is equal to row 3 minus 6 times row 1. So we write out row 3, which is 6, -2, -3, 0, 0, 1. I'm going to multiply row 1, all of those by -6. So I'm going to get -1. I'm sorry, -6, +6, 0, -6, 0, 0. And then I'm going to add these together. This is going to be 0. Here I'm going to get 4, -3, -6, 0, 1. This is my new row 3. So I'm going to write everything as it is. 1, -1, 0, 1, 0, 0, 0, 1, -1, -1, 1, 0. And now my new row 3 is going to look like this. 0, 4, -3, -6, 0, 1. Okay, notice how everything is going here. Notice how we have now the first 2 zeros in the first column, which is what we want. We want to get the identity matrix on the left side. And then the last one that they're going to have us do is row 3 is equal to row 3 minus 4 times row 2. My guess is we're trying to get rid of this 4 here. Yes. So I'm going to write down my row 3. 0, 4, -3, -6, 0, 1. Then I'm gonna do -4 times row 2. So it's gonna be 0, -4, +4, +4, -4, and 0. Whew. I don't usually like going this fast, but hey, interest of time. So 0, 0, 1, -2, -4, and 1 is going to be my new row 3. And so now we can write the finished matrix here, 1, -1, 0, 1, 0, 0. We're changing row 3, right? 0, 1, -1, -1, 1, 0. And our new row 3 is 0, 0, 1, -2, -4, and 1. Now, we're not completely done doing the inverse matrix, right? But we've put it in what we call our REF mode, where these 3 are zeros. And now you can look at what's left and match up the numbers here with everything that they give you as the answer choices there. Okay. So make sure that you take a good look there. In this case, just by a quick look, it looks like it is this guy right here, and the second choice right there. So make sure that you're able to do row operations and understand what they're asking you to do. Make sure that you can do them yourself to try to get zeros. Remember, that's the strategy. Don't worry about the ones. Try to get zeros. The ones will take care of themselves. The last thing I want to talk to you guys about, really, there's a whole bunch to matrices that we could do. I'm going to point you guys in problems like number 6 and number 7, and I think number 8 as well, to go look at the videos that I posted on multiplying matrices, adding matrices. That's matrix operations basics.
If you could please start making your way to the auditorium, we will have the meeting starting shortly.
Always fun to be interrupted. Right?
Again, thank you friends for coming out to Back at Night. If you could please start making your way to the auditorium, the meeting will be starting shortly. Thank you.
All right. Yay. Yay for that. I'm glad that one made it on the video. So remember that for this last setup, right, where you're going to need to be able to create the matrix equation, that you remember that these are going to be your X and Y values. They're typically going to give you the equation that they want you to use, like this x squared plus y squared plus dx plus ey plus f. They're most likely not going to ask you to actually solve it. For this, remember that you're going to want to use the inverse matrix on Desmos matrix. Anyone want to take a pizza? Someone please take a pizza home, okay? All right, fine. Yes. Okay, we already had pizza yesterday. We have pizza too much at my house. Okay. So to set up the equations, you're going to want to plug in the x's and y to each of these. So I'm going to start off with 4 and -2. This is my x and this is my y. So I'm going to plug it in. Ready? It's going to look something like this, right? 4 squared plus -2 squared plus 4d minus 2e plus f equals 0. When you're dealing with something like this is going to be most likely a circle. Then make sure you square these and add them together. 4 squared is 16, -2 squared is 4, 16 plus 4 is 20. This number is always going to end up being negative, whatever it is. So now I can write this first equation looking like this: 4d minus 2e plus 1f is equal to -20. This is my first equation, right? Then do the same for the other 2 points that they give you. The next one is -3 and 5. Watch, I'm gonna show you a shortcut. Okay, so I know that this is my x, this is my y, right? So I know it's going to be -3d plus 5e plus f is equal to, well, I'm going to take this number and square it. It's 9. This number squared is 25. Added together, those give me 34. So it's going to equal to -34. Oh, didn't that just become a lot faster? Yeah, it's the same process. I'm just showing you, hey, look, there's a shortcut you can take if you're careful, if you're cautious. The last one is the coordinate 6, 2. Oh, that's how tall I am. Hey, look at that. 6, 2. So again, I'm going to have 6D plus 2E plus F is equal to 6 squared is 36 plus 2 squared is 4. 36 plus 4 is 40. Is equal to negative 40 on this side. So once you have that, you can turn this into the matrix equation for negative 2, 1, negative 3, 5, 1, 6, 2, 1 times D, E, and F is equal to the matrix negative 2, 20, I'm sorry, negative 34, negative 40. To solve for D, E, and F, you need to have, you need to find the inverse of the matrix. For the quiz, make sure you use Desmos to finish this off. Find a inverse, which I'm going to write like this. Make this, call this A in the matrix calculator. Then all you have to, and then make this one B in the matrix calculator. And then all you have to do is type in A inverse times B to get the answer. And then you can write out your equation: x squared plus y squared plus dx plus ey plus f equals 0. Once you figure out what D, E, and F are by using that matrix conversion. Okay. And that's the basics of what you're going to see on the test. I hope that this was helpful for you guys and that you use the rest of the resources. Hey, I guess it's cram night for everybody, so I hope you all do a little, I hope you guys do some studying tonight. All right. Hey, this is what you do in college too. You go to a study session with your peers, you get free pizza or buy a pizza, whatever it might be, and then you cram. Okay. I know it's not the healthiest thing in the world, but to be honest with you, it's just the truth of what happens. You know, life is tough. It's full of challenges. It's very busy. You guys have all sorts of other responsibilities. And sometimes you need to, you know, study really hard the night before an exam. So I wish you guys luck. I root for you guys when you take your test, and I will see you all later. Bye-bye.